So, today we'll be looking at another volumetric analysis, that is titration. The question we have here said a solution containing 3.92 grams of tetrasulfur 6 acid per dm cube. B is a solution of sodium triazoxide carbonate salt. Then at A said put A into the burette and titrate with 20 or 25 cm cube of B using methyl orange as indicator. Tabulate your burette reading and calculate the average volume of A used. The next one they say that from your results and information provided, calculate the concentration of A in mole per dm cube, concentration of B in mole per dm cube, and volume of carbon 4 oxide liberated at STP. Then every other information, the molar volume of gas at STP is given to us at 22.4 dm cube. The equation of reaction is already given to us. Now this is the tabulated volume of the acid used or A used. We have the average volume. The volume of pipette used is 25 cm cube. So what we do here is that we are going to carry out the analysis, the calculation, in order to find the mole concentration of A. Then we also get the concentration of B in mole per dm cube. But before we do that, we need to calculate what the average volume of A used. The average volume of A used. From here, you find out that we have the rough titer is 20.4, first titer is 21.2, second one is 21.3, and the last one is 21.3. So in this case, we are going to use the 21.3, 21.0, the one that they are close to each other. So what we're going to do now is to calculate the average volume. So the average volume of A is, we take this one 22, 21.3 and 21.3. We have it to be 21.3 plus 21.3 all over 2. Everything will bounce back to 21.3 cm cube, 21.3 cm cube. So the next one said that we should calculate the concentration of A in mole per dm cube. To calculate the concentration of A in mole per dm cube, we were given the mass concentration of A in gram per dm cube. That is what we are going to do here is, then we know that the molar mass of the mass is what? 3.92 grams, and the molar mass of the acid or A, the tetrasulfur 6, is that summing everything we have here, we'll get it to be gram per mole, 98 gram per mole. That is to say, hydrogen here is 2 times 1 plus sulfur 32, and then we have 4 times 16. 4 times 16, everything will give us, when we sum everything together, you get this thing. We'll come back to this. So now let's quickly go down to what we are about to do. What we are doing here is then the mole concentration in mole per dm cube of A will then be 3.92 over 98. That will give us 0.043 mole per dm cube 0.043 mole per dm cube. So, or we can add it up, we can also round it up to perhaps 4. You can say it's 4. 0.04 mole per dm cube. Then the next one we're going to do is that we are going to calculate the mole concentration of B in mole per dm cube. So we have our concentration of our A to be this in mole per dm cube. So to calculate this A, the B now, we are going to use our formula. The relation that says that where CA is equal to 0.04 mole per dm cube, and then VA is equal to 21.3 cm cube, and then VB is equal to volume of our pipette, and then A here, let's go down here first, concentration, which we don't know, question mark, and then A here is equal, from here you see the mole ratio of A is what? Is 1, and that of B is also 1. So we're going to substitute for all these things. When we do the substitution, we will have so this is what we have. Then when we cross over, we will have it to be CB will be equal to 0.04 times 21.3 all over 25. That will give us 0.034 mole per dm cube. This is what we have. So the last one, so that we should calculate, we are going to calculate the volume of carbon 4 liberated at STP. Now we are given the molar volume of gases at STP to be 22.4 dm cube. So what we're going to do here now is to carefully compare what we have in our balanced equation. The balanced equation that we have here. If you look at that equation, notice that sodium triazoxide carbonate will liberate was 1 mole of sodium triazoxide carbonate will liberate 1 mole of, or 22.4 dm cube of carbon 4 oxide. So that is to say 1 mole will give us 22.4 dm cube of carbon 4. Carbon 4. Now we talk about what will this one give us. 0.034 moles of sodium triazo carbonate. What will it give us? It will then be equal to 22.4 over 1 times 0.034. So what will divide that? We will have it to be 0.762 dm cube. 0.762 dm cube. If we are to convert it to cm cube, what we'll do is that we'll multiply it by 1000 cm cube. Multiplying, we'll have 762 cm cube. That is the volume that will be liberated at STP. At STP, this is what we have. All right. Thank you so much for being part of it. If you have not subscribed, we want you to subscribe, share, like. Let us hear from you in the comment section. Any question you want to ask, you are free to ask. Is there? Ask us the question there. Let's hear from you. I'm looking forward to reading your comments. And if you would like to speak to us directly, you can also go to our description section there, where you will be able to access our Facebook page. From there, you can also communicate with us. Thank you so much.